Hey yo, what's up guys? BabyBear4812 coming at you one more time. Today we're doing problem 442, the find all duplicates in an array problem. It's currently being asked by Microsoft, Facebook, Bloomberg, Amazon, albeit it's not too popular. The reason I chose it though was because I thought it was a very interesting problem with a bit of a cheeky solution. Yeah, nothing more to it. Let's dive into it. The problem reads as follows, is that we're given an array of integers from 1 to n inclusive, where n equals the size of the array, and some elements appear twice, while others appear once. Find all the elements that appear twice in this array. Could you do it without extra space and in O of n runtime? Okay, can we do it, without extra space and in O of n runtime? So let's think about what we do if we ignored those conditions for one moment. So this problem kind of becomes a lot more trivial if that was the case, because we could do the following. We could say something like, what if we did O of n runtime, or maybe I'll say O of n time and O of n space. So in this case, if we used extra space, we could simply do this just using a dictionary. And what we do is walk through the dictionary. We'd collect I do apologize. I think that's my Slack. We would pick up the frequencies of all the numbers, and we just check through to see which ones appeared twice. Fine. Again, though, that would use O of n space. Time would be good, but space is too much. There's another option where we could use O of n log n, maybe n log n time, and use O of 1 space. And in this solution, again, I'm kind of naming the two trivial ones. This will just be to sort, then search, and we'd start by checking, well, since we're given the numbers from 1 to n in this array, and that's something we're going to have to keep in mind, if I sorted it, it would look like 1, 2, 3, 4, 5 up to n, and at some point, I would hit a number that looks like the previous number. I'd have 1, 2, 3, 3. Okay, once I see that, I know the 3 repeats. Those are both fine. Again, they're not going to get you very far in the interview. They're very trivial solutions, and they do it using extra space, either extra space or more than linear runtime. So then the question becomes, like, how do we do this without the extra space and in linear time? And again, I don't think the solution is all too obvious. I thought it was a really cheeky one, and that's why I wanted to go over it. So I've gone ahead and created this example, or rather, I didn't create it. I grabbed it from here, where the input was 4, 3, 2, 7, 8, 2, 3, 1. Upon quick observation, we could see that the 2 and 2, they appear twice, and the 3 and 3 appear twice. So we will output 2 and 3. And what we'll do is we're not going to assume that the output array takes up any space, because de facto it takes up space, but in the context of the interview, that's going to take up space anyways. We just don't want to use any auxiliary or additional space. And I'm going to wipe out these trivial solutions here. The one piece of information to know, if you kind of haven't locked your head onto this already, is that these are the numbers in the array. They're between 1 and n inclusive. Okay, if this wasn't the case, then we would have to kind of solve this problem very differently. But in this case, to do it without extra space and in linear time, we need to take care of this condition over here. So let's talk about how we do that. So if you've kind of sat down and thought about solving this problem already, you'll have seen that it's not, like, it seems really simple, but again, to do it this way is not trivial at all. And I was thinking about how to do a build up into leading into the logic of getting here, but I didn't really think of a clever way to show you, like, a logical buildup, apart from actually kind of letting the cat out the bag and talking through the method of well, how to solve it just directly as is. And so here goes nothing. Since these are the numbers, again, from 1 to n, it means that if I get some number or some index I get an entry, I'll call it n. So right here, let's say n is equal to 4. Since n is the number that I'm looking at, by extension, there must be some number in the array, or there must be some entry in the array whose index is n minus 1. So if these are all the numbers from 1 to n, then the array itself must, and n is the length of the array, then all the indices from 0 to n minus 1 must exist. That's 0 to n minus 1 inclusive. So what in the actually observing this fact, that I kind of said that lightly, but this is the key in recognizing this problem. And so what that means is, let's say I see a 3, okay? I'll erase this from, or no, we'll leave it, it's important. Okay, I see this 3, okay? If I see this 3, that means that the index at 3 minus 1 exists. So there's an index at 2, and I've written the indices here. So maybe I'll label this n for the numbers, and this is the I for the indices. Well, if I look at a 3, then that means there must be an entry at 3 minus 1, which is 2. It just so happens that that also is index 2, and the value is 2. So I've somehow, I recognize that this entry exists. So how could I go about identifying the fact that I see this number 3, and I acknowledge that there's an entry at 3 minus 1, which is right here. Is there any way for me to mark that entry so I can then say the next time I come across a 3 and I peer at that index, I say, oh, I've already checked this index out before. The only reason I could have checked it out before is because there was a 3 beforehand that's already checked it out. So imagine kind of going through, and I'm exploring. So I start off here at the beginning of the array, and I see a 4 here. My number is 4. I acknowledge that there must be an entry at 4 minus 1, which is 3. So at index 3, so I say I'm going to take a peek here. Okay, the trick we're going to use to mark the fact that we've taken a peek is just to turn this value negative. So I'm going to say the following. If I'm standing here and the value is 4, I'm going to say, let me look at the 4 minus 1 index or entry, that's right here, and make it negative. We know by default all the entries from the beginning are going to be positive. They're going to be from 1 up to n inclusive. So by turning it negative, it must be unique. I'm never going to have a negative entry by default. And we'll see why this works in a second. I now see the second number. This second number is a 3. And so I know that there exists an index at 3 minus 1, which is 2, so an index right here. And I check out my value here. This value is untouched. It's still positive. So I'm going to say I've found this. I've seen this value. I've looked at it. I'm also going to make it negative. Okay? I walk along. I'm now looking here now. Now, I see a negative 2. Okay? There is no negative 2 minus 1 index. I know that originally this number was just 2. It wasn't negative 2. All right? And then that's easy to verify. We can just take the absolute value of the value. And so I realize, okay, well, let me now have a peek at the 2 minus 1 entry. So I'll be right here. Now I notice that one's still positive, so I'll mark it as negative. I've seen this thing. Basically, here I said I'm going to check out index 3. Here I'm going to check out index 2. Here I'm going to check out index 1. I jump to this number. I'm going to say I'm going to check out index 6. 6 being 7 minus 1. So I go to index 6. I realize it hasn't been checked either. I'm going to mark it with a negative, okay? And again, I promise we'll get to the point where this matters. I take one more step over, so I'm pointing here now. And so I'm going to point at the 8 minus 1th index. I'm going to take a look at it. And I'm going to see, okay, well, this number is positive here. I mean, I'll have checked it out. I move along here. And I see the value of 2. Okay, so I say, let me check out the 2 minus 1th index. So that's 1. And I say, oh, well, this value is negative. If this value is negative, that means that I already have visited this place before. If I have already visited it, that means that there must have been a 2 beforehand, because that 2 beforehand, before where I am right now, triggered me to say, let me check out index 2 minus 1. And so that means that if this is my result array, that I have seen this number 2 before. And so I'm going to input the 2 into my result. I'm going to take one more step over. I'm here now. I'm going to take the absolute value of this number and say, okay, I'm going to look at the 3 minus 1th index. That's index 2. I check it out. Oh, index 2 is negative. That means that at some point I've checked out index number 2. The only way I could have checked out index number 2 is if there was a number 3 prior to where I am right now. Hence, this is a duplicate number, and I'm going to return a 3. We try the same business with the 1. 1 minus 1 is 0. We check this out. It's positive, so we haven't visited it before. And that's how we've created our result array in linear time with no additional space. And that's the algorithm. The code is going to be very succinct. And it's a deceiving problem in the sense that the solution seems very, very simple but not easy. And again, not obvious as I keep saying. So I hope that makes sense. Once we write out the code, I think it'll be clear. I think this walkthrough was thorough enough to really give you the lowdown of the logic from start to finish. If it wasn't clear, rewind it a few minutes and check it out again. If it still isn't clear, let me know in the comments down below as always, and I'm happy to address it and clarify any confusion. Now, let's take a look at what we got here. So we're told that we're given a legitimately sized array, so I'm not going to have to do any error checking. I'll start by just declaring my result array, and obviously we're going to return the result at some point. And here at this point, we said that we need to start doing a walkthrough through the array. So I'm going to say for some number in the numbers array, we're going to do the following. We need to check out the index at number minus 1. So I'm going to say if num's at, so instead of just going num minus 1, I'm going to take, like we said, the absolute value of num minus 1. The reason being is because we got in these positions where sometimes, I'd have already checked off one of these values as being negative. So I don't want to try to check a negative index minus 1. In Python, that won't actually throw an exception, but unless it's like overly negative. It's just that it'll give us the behavior that we don't want, because it'll start checking from the other side and not the index that we want. So I'm going to say that if in this array, nums, if we check the absolute value of our number minus 1 index, if that number is negative, we said, if it's negative, then we know that we have already visited this index. The only way we could have visited this index is if we actually, if we'd already seen this number before. So that means that we're going to have to append the absolute value of the number that we're checking out. Otherwise, if that's not the case, so if it's not negative, we have not visited it before. And that means that we're going to take that same number, so abs at num minus 1, we're visiting it for the first time, and we're going to multiply it by negative 1. We're going to multiply the number itself by negative 1 to make it negative, so if we come across it again or visit it for a second time, we'll acknowledge that it has been visited because it gives us a negative value, and we will append it to the result. Net of that is you run this code, it should run, I'm going to submit, and like I said, the code is very non-inspiring, right? There's nothing, I'm not moving any mountains here. It was a pretty straightforward piece of code. Again, the logic I think maybe wasn't as obvious. It was like, it's a deceivingly easy seeming problem. I definitely was ready to put my head through the wall when I first did it, and then it was like a dull moment of when I finally got like how to make this work. So I hope that you guys got hit with the same light bulb moment. I hope this clarifies it for you. Any questions, leave them down below. Like, comment, share, subscribe. I hate plugging that part, but I hope you do all those things. And I will see you guys next time. Peace.